Workers tend furnaces burning oils and resins in controlled conditions, flames producing dense black smoke that deposits carbon soot collected as the primary pigment for printing ink production. Heated linseed oil undergoes chemical transformation in large kettles, steam-heated cooking, converting raw oil into the thick varnish that will carry pigments onto paper during printing operations. Massive grinding mills crush pigment and varnish together, heavy rollers reducing the mixture to extraordinarily fine consistency, enabling smooth ink transfer and sharp printed images. Finished printing ink emerges from quality testing, displaying proper viscosity and color intensity. Systematic production creating the essential material enabling the newspaper and book printing industries, serving growing literate populations. This is just part of the systematic process transforming carbon and oil into printing ink inside this 1860s steam-powered factory. Before we continue with the complete process, if you could leave a like and subscribe to the channel, it would really help this project continue bringing historical industrial content. Thank you for your attention. Now back to the video. Carbon black represents the fundamental pigment for black printing ink, produced through controlled combustion of oils or resins that generates dense soot collected and processed into the fine powder that will color the final ink product. The factory operates furnaces designed specifically for carbon black production, burning materials in oxygen-limited conditions that promote incomplete combustion yielding maximum soot rather than complete burning that would produce only carbon dioxide and water vapor. Workers feed oils or resinous materials into these furnaces, maintaining combustion conditions that generate thick black smoke, carrying the fine carbon particles essential for ink pigmentation. The smoke passes through collection chambers where temperatures drop and carbon deposits on cooled surfaces, accumulating as thick layers of black soot that workers scrape away periodically to harvest the carbon black product. This collection process yields remarkably fine carbon particles, the small size enabling the smooth dispersion throughout ink that prevents grittiness and ensures sharp printed text and images when the ink transfers to paper during printing operations. The collected carbon black undergoes processing to remove impurities and achieve consistent particle characteristics affecting final ink quality. Workers may grind or pulverize the collected soot, breaking apart any agglomerations and creating uniform powder that will disperse evenly when mixed with oil-based vehicles during ink manufacture. Some carbon black production includes chemical treatments, removing unwanted compounds, or adjusting surface properties that affect how carbon particles interact with oils and paper during printing operations. The processed carbon black is stored carefully, protected from moisture and contamination that would compromise quality in subsequent ink manufacturing steps. The 1860s carbon black production relies primarily on natural oils and resins, though some manufacturers begin experimenting with coal tar and petroleum derivatives that will eventually dominate carbon black manufacturing in later periods. Linseed oil serves as the primary vehicle carrying pigments in printing ink, selected for its drying properties that enable printed ink to solidify on paper rather than remaining permanently wet like oils that never cure through atmospheric exposure. The raw linseed oil arrives at the factory in barrels, pressed from flax seeds at oil mills, supplying various industries using this versatile material for paints, varnishes, and inks. Workers transfer oil to heating kettles where steam-powered systems or direct fire brings material to elevated temperatures that initiate chemical changes, transforming thin fluid oil into thick varnish suitable for ink manufacture. This heating process, often called oil cooking or boiling, polymerizes the oil molecules through oxidation and other reactions that increase viscosity dramatically while maintaining the drying characteristics essential for printing ink function. The oil cooking requires careful temperature control and timing, as insufficient heating produces thin varnish lacking the body necessary for proper ink consistency, while excessive heating creates overly thick material or burns the oil producing dark colors and unpleasant odors degrading ink quality. Workers monitor cooking kettles continuously, observing color changes and occasionally testing viscosity to determine when optimal varnish properties have been achieved. The cooking process may extend for hours depending on batch size and desired varnish characteristics. with steam heating enabling precise temperature maintenance impossible with less controlled heating methods. Some ink manufacture includes additives introduced during oil cooking, materials such as resins or dryers that modify varnish properties and affect final ink drying time, gloss, or other performance characteristics important for specific printing applications. If you could leave a like and subscribe, it would help keep this channel active with quality historical content. Thank you for your attention. Now continuing with the process. The cooked varnish is cooled and stored until needed for ink mixing operations, the thick material displaying dramatically different characteristics compared to the thin, fluid raw linseed oil that entered the cooking kettles. This varnish provides the binding medium that will hold carbon black particles in suspension while enabling ink transfer to paper and subsequent drying into permanent printed images. Different varnish batches may be prepared with varying properties suited to different ink types, with newspaper inks requiring faster drying formulations, while book printing may use slower drying inks that enable more careful press operation without rapid drying interfering with printing processes. The ink mixing operation combines carbon black pigment with cooked linseed oil varnish, creating the initial mixture that will undergo extensive grinding to achieve the extraordinarily fine dispersion necessary for quality printing ink. Workers measure pigment and varnish quantities carefully, following formulations that specify ratios producing inks with proper color intensity, consistency, and drying characteristics for intended applications. The mixing equipment may include simple stirring vessels or more sophisticated mechanical mixers that blend materials thoroughly before the grinding operations that complete ink manufacture. This initial mixing distributes pigment throughout the varnish base, though the particles remain relatively coarse and incompletely wetted until grinding operations dramatically reduce particle size and improve pigment dispersion. The grinding process represents the critical manufacturing stage that transforms coarse pigment mixtures into smooth printing inks, displaying the fine particle dispersion essential for sharp printed images. The factory employs heavy grinding mills, typically 3-roll or 5-roll configurations, where ink passes between massive steel or granite rollers, rotating at different speeds. These rollers crush and shear the ink mixture, breaking apart pigment agglomerations, and forcing varnish to coat individual particles thoroughly while reducing everything to extraordinarily fine consistency. The mechanical forces involved in grinding prove substantial, requiring heavy mill construction and significant power input from steam-driven machinery that maintains roller rotation throughout extended grinding operations, processing each ink batch multiple times to achieve required fineness. Workers feed ink mixture into the grinding mill where it enters the gap between rollers, the narrow clearances, and opposing rotations, creating intense shearing forces that grind the material. The ink emerges from the mill considerably finer than the material entering, though multiple passes through the grinding equipment may be necessary to achieve the particle size and dispersion quality necessary for premium printing inks. Workers periodically test ink fineness using simple tools or instruments that assess whether particles have been reduced adequately or require additional grinding operations. The grinding generates considerable heat from friction between rollers and ink, sometimes necessitating cooling systems that prevent excessive temperatures degrading ink quality during processing. The ground ink undergoes quality testing to verify proper consistency, color intensity, and performance characteristics meeting specifications for intended printing applications. Workers spread ink samples thinly on test surfaces, examining color uniformity and absence of visible particles that would indicate inadequate grinding. The ink consistency is assessed through viscosity measurements or simple spread tests, evaluating how the material flows and whether it displays the body appropriate for the printing method where it will be used. Some quality control includes actual printing tests where ink is applied to paper, using small hand presses or printing equipment, enabling assessment of transfer characteristics, drying time, and final appearance under conditions approximating actual printing operations. Different ink formulations serve various printing applications, with newspaper inks formulated for rapid drying and economy, while book inks prioritize permanence and appearance over drying speed. Colored inks require different pigments beyond carbon black, with manufacturers preparing red, blue, yellow, and other colors using mineral pigments, synthetic dyes, or natural colorants processed and ground into oil vehicles through the same basic methods used for black ink production. The 1860s represent a period of expanding color ink production as improved synthetic pigments become available, and printing technologies advance to enable multicolor printing in commercial and artistic applications beyond the predominantly black text printing that dominates earlier periods. The finished ink is transferred to storage containers, typically metal cans or ceramic vessels, that protect contents from contamination and moisture while enabling convenient handling during distribution and use. Workers fill containers systematically, measuring quantities precisely to ensure consistent product volume across production lots. The filled containers receive labeling identifying ink type, color, manufacturer, and sometimes batch information enabling quality tracking and customer support when questions arise about ink performance. The warehouse accumulates diverse ink products, serving various market segments, from economy newspaper inks to premium formulations for fine book printing or specialized applications requiring particular performance characteristics. The printing ink industry serves essential roles supporting the expanding publishing and printing industries that supply growing literate populations with newspapers, books, commercial printing, and other printed materials. The 1860s represent periods of dramatic printing expansion as improved presses, cheaper paper, and rising literacy drive unprecedented demand for printed materials requiring corresponding ink supplies. The ink manufacturer's ability to produce consistent quality at industrial scale proves crucial for printing industry development, as variable ink quality would create production problems and inconsistent printed material, degrading publisher reputations and reader satisfaction. Inside steam-powered printing ink factories like this, chemical processing and mechanical grinding transform carbon soot and vegetable oil into the specialized materials enabling printed communication. The machinery continues operating, prepared to receive new batches of carbon black and cooked varnish for repeating the mixing and grinding cycles, creating the inks that enable information distribution through printed media. Steam power drives the grinding mills and heating kettles, while providing mechanical energy for mixing and handling equipment, enabling efficient production serving growing ink demands from the printing industry. Workers combine traditional ink-making knowledge with industrial chemical processing, maintaining quality while achieving production volumes supporting the publishing expansion, characterizing this period of growing literacy and print media development. Did you know that the grinding mills used for printing ink were so powerful they could reduce materials to particles, measuring only a few micrometers, creating the ultra-smooth consistency essential for sharp printed text? If you enjoyed learning about industrial printing ink production from the 1860s, please subscribe to the channel, leave a like, and comment about what surprised you most. Your support helps us continue bringing historical industrial content. Thank you for watching. See you in the next video.